Hello everyone. Now we look at the week 6 lab exercise. Right. Click here, we show look at the exercise. So in this week the exercise is relatively easier because we're going to have more focus more on the assignment, right? It only have 2 tasks. Actually it's 1. So it's improve the user interface of game screen, right? So look at in this exercise, we continue building the animation-based application from last week. So we continue working on that one, improve the user interface, redesign the layout so the games area for the and the back button are displayed separately like this one, right? And the second one is refactor the code using the first 3 grasp principles, right? Okay, so we just look at this part first. Come to here, we try to just show you where I found the code. If you still have your code from last week, then you just use that code to as the base to continue working on that. If you don't have that, you just come to the website, GitHub Larry at you found the Java animation from this project, right? You go to this page, come to the code, click here, and then go to the next part, git clone this, so you clone the project. And then you can open the project. This one put into download Java practice, right? So it's on the practice here. This window. Okay, then we have this project, right? We have this project, and we can have a look about that. Git. Okay, the current is in the main, right? And we look here if we run this project plugin JavaFX. Okay, so it's come to our earliest version of this code, right? Okay, right. Let's just check branch, look at it remotely. Okay, look at the remote part. We have 3 branches. This is the main, right? Apart from main, we have other 3 branches. Lab 3 feature, Lab 4 feature, Lab 5 feature, right? So that is the branch for the feature to be finished for each week. Now we look at the feature we get from check out Lab 4. So that's what we have finished last week, right? Okay. All right, so this is for the last week. We can run the code. All right, so this is what we have done last week, right? We look at this still here, but for the configuration we have this, and the others still the same, right? Okay. Now we look at this week's exercise. The first part is try to change this layout, therefore it's come out like this way, right? So it's consistent with the configure page. We have back at the bottom and the game area here, clearly marked area, right? Okay. And the next part is to refactor the code using the first three grasp principle. First one is information expert. So in the original design, if we look at this code, so that's from last week, we have the game screen, right? And in the game screen, look at the major part is for the game, right? For the game section. Okay, so look at here. So the X is the ball get center X. So the X is actually captured from the screen rather than by the game itself, right? And get the X. And eventually they assign this to here, set center X, set center Y to that part. Okay, so that means the location of the ball is controlled by the view rather than by the game itself. The game doesn't hold this information, so we need to change that. So that is one part. And also look this section. This is for the control, right? If some key press happens, so they're going to get this part. So the controller part is also in the game screen class. Okay, look at the game screen class. It has game screen and then the controller. Also start the game, manage the game logic. Here is actually the game logic, right? So if the bounce. So, and here is the build screen to print out the create the component in this game. And so you can see the task for the game screen is too many. They have back button that return to the previous screen, right? And also they manage to create component in the game, and also manage the game logic here, and also manage about the controller part, right? So we can see this class is too heavily built, right? Too heavily built. So in that case, we look at the requirement for this week. We information expert, we make the bouncing and the ball movement back to the game class, because that game is the data, right? Control the game data. So this should be in that class, right? And the creator, since the game area is not a distinct part for the game screen, right? So create a new class named game pane. So this game pane is only responsible for managing the game view, right? Game views, rather than also need to worry about the red back button controller bar. Now we need to create a controller, introduce a new class called game controller to handle key press event, right? So that is the task refactoring for them. Okay, so we look at this code because to change the code takes probably a few hours. So that I'm probably not going to redo the changing process. I'm probably going just to show you the difference between this is a last week's version and the new version, and also explain the final code. Right? So actually, if you go to the GitHub from here, not this one, go to the GitHub. Go to the GitHub one. Okay, if you go to GitHub, see they have 4 branches here, right? And one interesting thing here is you can go to this pull request. From this part, you can do the uh, comparison of the branch, right? If you click on the new pull request, and then here you can make a compare. So this is compare the latest branch and the previous branch, right? Here you see from the lab 5 feature, that means the feature finished after this lab compared with features from previous lab. So in this part we can see what has changed, right? So probably increase the size a little bit. So here see we have the env.java, right? So that's a new file create. So this one is only for some constants, right? Because I don't want uh, the main class host too many data here, so we create separate one just for the constant values, right? For the main class we're going to look at the details, right? Great. Right, for this main class, and this is the new class game pane, right? So this one is dedicated only useful to handle the display of the game, right? Handle the display of the game. And we can see the game screen. This one has been changed a lot because originally the game screen class has a lot of functions there, right? So now we move many of them, remove the controlling part, remove the game logical part, and but add, of course, add the game pen section. So can remove also yes, for the build screen part we also made some modification. Later on we look at them because this ball creation should be in the game pane, right? Not in the game screen, right? Okay. And also we create a new class called game controller. So this is going to manage the game control. And for the game object, we remove some of them like getDX, getSetDX. So this kind of function we're not going to require anymore because we put logic, most of the logic within the class itself, right? So the proceed. So this is the game logic when you run the game. So this section is responsible for the game part. Okay. All right. So this is just a general overview of the change. You can always come here because for the project for multiple people, if you want to merge people's work together, usually they create a branch, and before you merge, you create the difference between the new file and the old file, and people can read this one. They can put on review comments here, and eventually everyone happy with this kind of change, they can merge. But of course, for this one, we don't need to worry about them. It's just demonstrate how could you can compare the change from different branches, right? Okay. Now we go back to this one. See, this is in the previous last week's implementation. Now we go back and change to this week's the latest implementation, right? Check out lab file feature. Okay, I see now we are in the lab file feature. Now we have run this. Look at the difference first. And then I'm going to explain the code one by one, right? Okay, look at this. This one, the configuration is still the same, right? And the start game thing, now it have changed. So we have clearly it's the game area, right? Game area, and here is for the button, right? Make it consistent, right? if we change that, start game, say change, right? So the function is still right. Now we look at the code. Firstly, look at the design, because maybe it's right to show you. Originally, when we start game, this is a game area, right? And also we have the entire window is same size of the game area. But now we look here, we see the game area, they have some gap around here, right? So therefore we need to create the size of that. So in this, to do this, I use this function. Let's create a new create a new class env, right? So this env, so this just holds some constants, the horizontal margin. So this is the margin here and here, right? And the top margin 10, and the bottom margin 80, right? So let's just give this margin, and then we come to here. We create the we create the scenes, right? The scenes, we still have the scene, but this time we use game field plus 2 of the horizontal, give this space, and also the head is field head plus top margin, and also the bottom margin, right? So we create here, so give it enough space. Okay, and we look at the game screen. Okay, so this file has been significantly simplified, because originally we have the now we have the create the bottom pane, right? So the same as the configure file. So we have return button, and once they click them, they go into stop games, right? And the parent game pane stop game, and parent show screen, right? So that return to them. Here, just add the CSS style class, CSS class, right, to make the size. This line is special. This line set focus traversable false. The reason to have that is because for this one I can use the button, say to increase the vertical speed, reduce vertical speed, increase the horizontal speed, and reduce horizontal speed, right? So we can use the key button to click them. But if because I use the arrow keys, right? If I don't have this one, what happens is if I press the down key, right? The direction down key, the focus will go to this button, and therefore this screen will not be able to capture the key price. So therefore, if I once press down, it will not going to capture the other key, the direction key anymore. So this function is just prevent this button to receive the focus. So therefore, focus is always on here. So that means always be able to capture the key button. So this is a very common problem for JavaFX and something like that. If you try to create something, try to capture the key stroke, key price from the system, always be aware that focus should be in this area, right? Not going to other parts. So that's something we need to be aware. Okay, button new stack part. So this just try to insert the space, make it right. Now we look at the build screen, right? So build screen is to build the entire screen of this part, build screen. So with stack pane, we have the border pane, right? New border pane. So because this is a border pane, we have two-part border pane, and stack pane. Okay, so we see we have a game pane on here, but because we want game pane be able to have some space here, we also create a stack pane to wrapper the game pane, right? And also make the wrapper pane has in the middle, right? And also set padding here, so that gives this extra space, right? Give this extra space. Okay, so that is for building screen, and we see building screen here. Okay, and the border pane top part is the game wrapper, and the bottom part is the button created from here, right? So generally, this two function is just to create this layout, Set game. So this time, the set game is calling from the main class. We don't create game in this class anymore, because in this game screen we're not going to maintain the game information. So we don't have game, we only have parent, we have the game pane, so that's this one, we have the border pane, that's this one. Main screen is okay. Main screen is actually is this itself. It's called main screen, right? Okay. Okay, sorry. Main screen is actually from the parent from the parent part. Okay, look. I see what is the main screen. Show screen, main screen. Yes, so let's go to the parent part. Yes. Okay, main screen is set back bar. Okay, and just let me see what is the frame. All right, what's the frame? Parent. Yes, parent and the main screen, actually they are the same thing, but here we know parent is a frame, but main screen is something just this frame going to direct to, right? Even though they are actually go connect to the same object, but here they use two different interface to control them, right? So for this one, it doesn't really know the relationship of these two, right? But actually they are the same. Okay, look this set route, right? If you back main screen equals this, right? So that can jump to, right? So get screen, they return the board pane, right? So for this screen, for this screen, if you want to display them, is in the border pane. Okay. Set game, we have game pane, set game, right? So look at this subtle difference between here. Now the other thing we need to think about that is this one. So the game pane, so the on property add listener, if it become visible, it's going to check if, check if the new scene is there, not now. If not now, the game pane is going to start game, right? Okay, so this logic for this game screen is clear. Display this two part, right? Just manage them and doesn't relate to any other extra things. Now we come to the game pane. So this is a new class. It's responsible for the drawing of this section, right? Okay. So we have animation timer, circle is the ball and the game, right? Okay. So once we set games, so that set game is calling from the game screen setting game. This game equals game, right? And then we have the timer create. So that means once timer execute, the game proceed, right? And also the ball set center game position, right? So since we see, we're not going to check what is the ball in the current screen position. They only need to worry about where the game wants the ball to be, right? So get position, right? Proceed, get position. So this is just set the timer to do that. But this timer is not start until you start game, right? Now we look at the build game pane, right? Build game pane. So this one is create the instance to create. First we create the rectangle, new rectangle here, right? Create a rectangle, right? Set color, transparency. So this is create a rectangle, and this part is create the ball, right? Ball equals this get color if the game. So you see this size, color, also all from game, right? And game has shadows. We're going to create shadow, but if not, we don't have shadow, right? And then we add this field and the ball to this because this is a pane, right? This is a pane to add to this pane. And request focus. So every time we come here, we're going to build the game, we're going to request focus. So stop game, the timer stop, right? So stop game is called when we leave this page, and this screen going to call the pane stop game. And start game, once they have start game, they build the game pane, call this section. So every time they start game, they build this, create this too. And also set the timer start, right? So you see this, the structure become much clearer, right? Much clearer. And we look at another new class, because for this one, another new class is controller. Under the controller, we have create a controller, right? We'll create a controller. So for the controller, we have the game, right? Because controller needs to have game, and create controller, the game is assigned to it to make it simple, right? And also this kind of injection, dependence injection, right, from the solid principle. And also here this one they have receive key price, key code, right? Once received, we depend on the value of the key. If it's up, game dot increase y, down game dot increase decrease y, left increase x, right decrease x, right? So let's look here. So how could this one? You see, this is not directly related to the game pane, right? If in the game pane they don't really know anything about the controller, and even in the game screen they don't have any information about the controller, right? So the controller is create when the game is create, because we look at the controller, it has game here, must have game. So where is controller create? It's in the main class. Here we have game equals new game, right? And game controller equals GC new game controller. We put the game there, right? Okay. So it seems nearly done, but the problem is how could the game controller receive the controller information? Because we have scene created in this stage, right? So we have scene set on key price. If scenes get on key price, have event, and we use this lambda expression, right? We're going to call GC, right? Game controller receive key price button, right? So it's here. So after we register that, we don't need to worry them anymore, right? So The last thing I'd like to mention is about game class. The game is now we look at the DX, right? So DX, all the set and getter for DX have been removed because we don't need to export DX to anywhere, right? For the X is the location of the ball, right? The initial value is this in the middle, and we only have get X and get Y, so that just the getter. For this, we don't have status. So the position of this totally depend by this game class itself, right? Has shadow, get shadow, this controlled by the controller section, get color, string color, that's not changed. Size, get size, okay. So we can see the increase X, this just like we have done before, right? Increase X and sorry, this shouldn't be break. So decrease X, increase Y inside. So that's the previous version. Now we look at the proceed. So this is the game logic. We have been moved from the originally in the game screen and then in the game pane and now in the game one because it's purely related to data, has nothing to do with the UI, right? Has nothing to do with UI. So proceed. Once they proceed, we have the X, next X here, next Y here. If so, this logic is same. If this next X smaller minus S smaller than 0, so probably we don't want this ball go beyond the border, right? If it go beyond the border, we're going to change the direction of the speed. Dx equals minus x. Same thing for y. And then after we make that, we can just say that x plus equals dx, y plus equals dy. So let's give the new position of the x, right? The proceed. Okay, so look this part in the game section. Once the timer started, the game proceed, right? Once the proceed, the ball is going to set the new position. Now you can see the new structure for the for the game. Even though the function is the same, but becomes much clearer and simpler, right? So that's just by applying the object-oriented design principles like this. This time we use the grasp. Look at use grasp. Have three principles. Information expert. Try to put information within the model class. In our case, it's game, and also the game logic in there because the game logic relate to the game so closely, right? The proceed here. We have creator to create this game pane within our screen pane, right? We have the controller. The controller is a new class. So later on in our class, we're going to learn another architecture design pattern called model view controller. Model holding the data. View is display represent the data. Controller is just in the middle. So in that model view controller, they have a controller, right? And in this one, based on the grasp, we also have a controller. So theoretically, these two controllers, they have certain kind of similarity, but they are still slightly different. The model view controller, that controller is more related to the UI section. It's UI, so you hold with the command part. But the controller in the grasp here is more related to your data model. So that is just a way to trigger the data model to do some exercise. So that is the slightly difference. But this kind of difference probably only can be reflected properly in a very large system. For our small system, like smaller games, usually these two kind of controllers, the boundary between them are very weak, so this looks more or less similar, right? So in our course, we probably just consider they are the same concept. The controller is sometimes is receive command from the UI, right? And the UI combine the controller probably into some command classes, command objects, and then this information is going to pass to the model model classes to process to trigger the model classes to do some logic processing, right? So that is okay. Let me look at how long I write. So this is for today. It's for this week's lab. So it's not many homeworks. Now probably quickly go have a look about the lab quizzes, right? Lab quizzes. Okay, sorry. I need to change to the student view. Okay, begin, right? I haven't done this yet, so I try to work together for the lab quiz. So I hope you can do this a couple of times to help you to review what you learned in this lecture, right? Come on, okay. Okay, fill in the blanks. One part, the value of V is level 3. Look at descriptor character screen. When descriptor string integer do descriptor, right? Describe level 3. Right. Okay, so you see this is generic data type, right? Descriptor string and integer, right? So this has a string and an integer, and then they have text number, right? So this type, right? Okay, return text to here, right? So describe level 3, so that is text number, right? Return to text to integer value, right? So that should be level space equal space 3, right? Just make sure space here, space here, right? So level equals 3. Okay, next. And this one, because I think for Java, the generic data type could be something very challenging for the programmers at beginning level. So we try to do more like this kind of exercise to read code with this kind of generic data type, so we get familiar to that, not feel too frustrating by reading them, right? Okay, let me see. Main resource handler bad input, new resource handler, right? Okay, better strip and new bad 0, right? Save close bears, right? Save close bears, right? T extend auto closable, so this is auto closable. Close return true, right? Okay, yes, that should be okay. True. Auto close return true, except return false, because this is just a string, just a array of bytes, right? Array of bytes and size 0, right? And this is closable, right? So, right. Okay. Next, according to PECS, right? PECS, that means what's that? The consumer, so that's a producer extend consumer super, right? So that's rules when you use this super, so that's the consumer super, right? Is in the method t is treated as a consumer, right? Remember this? The producer extend consumer super, right? So this consumer super, because this is super, so that's consumer. So this T is going to be a consumer. Consumer means you are able to create new instance for them. You write instance to this, but not read from them, right? So that's consumer. If the producer, you can read, but you cannot write. So that's difference. This is very, very tricky difference between the consumer, producer, and also this wildcard type. Okay, which class should typically handle placeholder button event in a design? Placeholder. Which class should handle? So it's handler, right? Okay. Order controller, item service, well designed or system handle this. Yes. So handle the user event. Usually used called controller, right? Order controller. Look at this code. The pair, they have two generic type, T and U, right? T is first, U is second. Pair, right? Get first, return first, get second. Okay, look, code pair string integer P new age 32, right? Integer get second, return second, return 21, right? So this 21, right? What is the primary goal of GRASP principle? To guide the assignment of responsibility. Yes, so that responsibility for object-oriented design. For the old design, you have many classes, but how you create different kind of classes, what kind of purpose of each different classes. This help you to define different kind of classes and assign the responsibility to them. Database to create user-friendly. Okay, no, they're not them. So it should be this one. This one, car, brand, year, okay, and yes, list, okay, car, right? So try to read this as many example of this as possible. So get familiar to reading, at least read this kind of generic data type. List car list array as list, right? So we have three cars, right? Toyota, Ford, and here a list sort comparator comparing car brand. Okay, so they compare based on car brand, right? Car brand. The string is brand, right? Car brand. Get to brand, right? Okay, so look this compare with them and also sort based on brand. We know the string is sorted based on the nature order of the alpha beta. So B, F, T, T should be last, first, middle, right? We got the second. The second is the last one, T, right? So this should brand should be Toyota, right? Toyota. Which view type would most likely describe how source code map into Git repository artifact? Viewpoint should most likely describe how source code map to GitHub repository, right? So that is source code, so that is the software element, GitHub repository, that's the environment element, right? Software element to environmental element, so that is allocation, right? Allocation, not CNC. CNC is runtime. Module is static between different module, different classes, but here is this repository, that's the environment. Behavior real type, no, not this at all. What would be a valid reason to use extend, right? So here extend, compare. Okay, so this is P for producer, right? To enable in a method signature, extend comparable to enable comparing element in a type safe. Yes, so enable the compare to allow a thin element of comparable, not strict to allow any type regardless to strict matter used only. enable comparing, right? Extend comparable in a type-safe way, yes. So it should be this one. Which view type helps map software element to physical structure such as server and container? So that is allocation view, right? Which view type helps to. Okay, let's see how many questions left. Okay, fill in blank. Employee implement comparable. Okay, this age compared to, right? Compared to based on the age. Okay, compared to. And we have the main, we have this and sort now, right? So it means we sort this and now that means we don't use any comparator. We use the employees comparable capability compared to, right? So one employee compared to others, this age to other age, so that is in the nature order. So that should be from low to high, right? So 35, 40, 30, 45, 50, name. Okay, so the second one, Bob, right? This one, main class, main list. So this is wildcard. So once we have this kind of list, that means we cannot write anything apart from now. And when we read, we can only read object, right? We can read those, even though here is integers, but we can only read as object, right? The reason is for this one, it can hold any type. So therefore, when we read them for any type, we don't know what type is. The only way we can use is object. Okay, what's the value of v, right? 0, so that value is 5, right? Even though it's read as object, but actually it is an integer, right? So it's 5, the first one is 5. Yeah. Main list, right? So that's also the wildcard array as list ABC, right? Get 1. Okay, what is sector? Okay, this should be B. Okay, this should be B. Yeah, so because we have the question bank larger than them, so usually sometimes they have quite similar question appears, right? And map, new hash map, right? New hash map, string. So put a map to apple, get a, right? Get a, return apple, right? Okay, so that's the key and get the value, right? Put here, hash map. Yes. Okay, 100. All right, so you think I have done this by myself. I hope you can try to do this exercise maybe multiple times. And if you found any question, if the answer is not correct, please just tell me because I cannot guarantee all the question get the correct answer. Sometimes they could make the wrong question or wrong answer is possible, right? But generally it should be right. Okay, generally should be right. Okay, thank you everyone. So that's all for this week's lab exercise and the quiz. Hopefully you can enjoy this exercise. So thank you. See you.